Today we're going to do a little review of the states of matter, which we talked about some in class today with our simulation. Right, the first state of matter that we're going to talk about is the solid. So solids, as we saw in class today, have particles that are very close together, and they have a very defined shape. So if you think about a brick, for example, which is a solid, if you move that brick to the counter, or you move it into a beaker, or you move it outside, the shape still stays the same. So solids have a set shape because their molecules don't move very much, or the atoms. Solids also have a set volume. So if you take that same brick and you were to heat it up, it doesn't change the volume. It doesn't suddenly have a larger volume or a smaller volume because the temperature changed or any other factor like that. All right, compressibility. Solids are not very compressible, and that's because the molecules or atoms are already very close together. So regardless of putting pressure on them, they don't really compress anymore. Okay, and since they're so compressed, you can see that the spacing between them is quite small. All right, the interaction between the atoms or molecules in a solid is very high. They interact a lot because they're so close to one another in space. And their motion, though we learned that with thermal motion, every atom or molecule has some amount of motion unless it's at absolute zero. The motion in solids is actually relatively small compared to what you find in liquids or gases. All right, now liquids. So liquids do not have a set shape. So if I was to take the liquid in this flask that's shown here and pour it onto the table, it would now take on a very flat shape and spread out all over the table. If I were to pour it into a glass, it would have more of a cylindrical shape instead of the slightly conical shape it has in the flask. So a liquid takes on the shape of its container. Liquids generally have a set volume, so just because I were to transfer this liquid from a flask to a beaker or to a glass or to the floor, the volume of the liquid is going to be the same. Okay? In terms of compressibility, liquids can be compressed a little bit more than solids, but really they don't compress very well at all either. The main difference with liquids and solids is that they're moving more, and so that is what gives them their fluid properties, but they're still very close together in space relative to a gas, for example. Okay, so in terms of spacing, like I said, they're very close together. And in terms of interaction, because they're so close together, they interact quite a bit. The interaction is not as strong as in solids because the liquid molecules are moving around a lot more throughout space. All right, and the motion of the liquid, as I just said, is more than in a solid. The molecules not only vibrate, or the atoms vibrate in their space, but they also move about throughout the liquid and don't stay in one set place like they do in a solid. All right, now finally we have gases. Gases do not hold one specific shape. So if you were to transfer this gas from a flask to a glass or even open it up to the air, it's going to fill that whole space. So it's going to take on whatever shape the container it's in has. All right, in terms of volume, like I said, it's going to take up whatever space you give it. So the volume of a gas is not set. It's determined by how much space it has to spread out. So if we were to open up this flask and these gas molecules could escape, they would take up the whole space given to them in the room. All right, because gas molecules are so far apart, they can be compressed. So we can put gas under pressure and squeeze it into a smaller space than it would be otherwise. All right, and in terms of spacing, gas molecules are the farthest apart of all of the different states of matter. As you can see here in this flask, the molecules aren't even touching one another. And as a result of that, they have very little interaction with each other. In fact, we generally assume that gas molecules don't interact with each other at all. All right, and as you saw in class today, the motion of gas molecules is the most of any of the three states of matter. They're constantly moving, bouncing around off each other and off the sides of the container, and they have lots of kinetic energy. All right, the last thing I want to talk to you about today is phase changes. So Some of these terms are going to be very familiar to you, so I would assume that most of you know that if you go from a liquid to a solid, that's called freezing, and going from a solid back to a liquid would be melting. Okay, those are called phase changes. All right, when we go from a liquid to a gas, we call that evaporation, and if we do it at the boiling point, we call it boiling. All right. When we go from a gas back to a liquid, that's called condensation. And you've probably seen that happen in the summer if you have a cold drink and the warm air condenses on the side of your glass and leaves a wet residue on the outside. All right, and then though you don't need to know these words for in terms of definitions, for completeness, I just want to tell you that going from a solid to a gas is called sublimation, and you've probably seen this at Halloween when you have dry ice that goes right to the gas state. And then going from a gas back to a solid, this is usually one students are least familiar with, that's called deposition. And probably the way you'd be most familiar with that is in your freezer, gaseous molecules of water will deposit as ice on the sides of your freezer. That's why you have to defrost it every so often. That's deposition. Okay, so that wraps up our discussion of the states of matter. And then tomorrow we're going to talk a little bit more about gases.